Okay, dear students, I welcome you for the second lecture of heat transfer. Today we are going to discuss the different household applications, then the different heat exchanging equipment and their purpose, and the most important aspect of this heat transfer related to the campus interviews, the questions being asked in the campus interviews. So let us start. The our household purposes when we talk, that is related to the different household equipments. Now for that purpose, basically what is the heat? Heat is nothing but a form of energy. That is a form of energy, and it moves with the transfer of thermal energy from a substance at a higher temperature to the another substance at a lower temperature. That is what a gradient is observed. Because of temperature difference, the heat transfer takes place. Because of the concentration difference, mass transfer takes place. So this heat transfer is transferring the heat from higher temperature to the another substance at lower temperature, or the same substance which is the another end having the lower temperature. So it is because the temperature difference which is leading to this subject. You have to only understand that the temperature difference at two different points, that is going to make a different individual subject to learn in the engineering. That means we are applying the various different mathematical formulas and applications in this subject, so that we are trying to analyze this subject in much details by considering the various aspects also. Now, in this figure, you can see a rod that is being heated, and gradually it's initially the red zone that is there, and gradually it attains a constant temperature throughout. So this is what we are going to heat and observe its effect. Slowly the uniform temperature of the rod that can be obtained. Similarly, the second example that is also there, you are putting a vessel or holding a vessel over a burner or over a flame. Now in this process, all the three modes of the heat transfer that will be observed. The heat that is from the direct flame, it goes to the vessel, that is by the process of radiation. By the process of radiation, then that is going to increase the vessel temperature. The metal wall of the vessel, its temperature that will be increased, and the after that the convection that is observed, and it is nothing but the fluid which is getting heated. The fluid molecules which are in close contact with the metal wall, the fluid molecules which are very close contact with the metal wall, that is getting first heated, then those molecules which are heated becomes lighter and moves in the upward direction. After that, the heavy molecules which are colder, they move in the downward direction, and a thermosiphon loop you can observe. Higher temperature molecules, they move in the upward direction. However, the colder molecules water molecules, they move in a downward direction. This is nothing but a convection. Then the metal vessel that is heated and that is connected to a handle. Now, as a result, slowly this handle also increases its temperature because of the conduction. That means first metal wall of the vessel that is heated, it is going to increase or supply the heat or the provide the temperature to this handle, and as a result you can feel the temperature, higher temperature in the handle also, which you can observe in this figure also. From one end it is heated, however it gradually attains a uniform temperature throughout the vessel, throughout the rod. So this is the most common example in our day-to-day life, that is a burner and a vessel. Now, when we put certain material or certain vegetables, we put it. So they get heated. As a result, because of the evaporation, the water molecules leave those vegetables, and when a lid that is kept on those vessels, that lid upper part is at a cold, lower temperature. So when the vapor molecules which are produced from those vegetables, they move to this upper part. This upper lid is at a lower temperature, so their condensation takes place, and the condensed water molecules, they move downward, fall on the vegetable, and the process of dilate that is going to take place, process of cooking that is going to take place. So the water, sometimes you are adding extra water, or sometimes the water itself from the vegetables that helps for the cooking process. Also, in case of a pressure cooker, we are putting the rice and the pulse in the pressure cooker. We put certain water and put it over the gas burner, so that it slightly increases temperature. One whistle blows, second whistle blows, third whistle blows. After that, sometimes we reduce its speed. However, we have to maintain the higher pressure in the pressure cooker, so that the material which is available inside this vessel, that will be cooked at a faster rate. So by increasing the pressure, we are increasing the temperature and obtaining the faster rate of cooking. So similarly, the process of boiling, that is also there, that can be observed when you put the water in the vessel. Initially, the small bubbles that will be formed on the lowermost portion, which is attached or which is closer to the flame, and these small bubbles, they move upward and get disappeared in the process while moving up. After some times, these small bubbles, they move up to the top, because the temperature of this liquid, that is at a sufficient condition where the bubbles which is generated from the bottom of the vessel, they move up to the top. Similarly, the evaporation of a milk, that is also getting observed. We make some rabdi, that is the evaporation of a milk, that is the concentration. We are concerned with the concentrated milk. That is what is our concern. In that process also, sometimes we put a certain plate so that whatever the bubbles that will be formed, those bubbles are going to burst by this plate and the liquid will not get overflowed from the vessel. So there are certain day-to-day life processes we are concerned, but all these processes require the good understanding of heat transfer. Similarly, when we put a certain chapati on the pan, then that gets heated uniformly, and once it has attained a certain temperature, then we put it directly on the flame. Then and only then it bubbles completely. So after attaining this certain temperature, the vapors will be generated at a faster rate. Then and only then vapors bubble will be formed inside that chapati. So all these processes, if you put the chapati directly on the flame before attaining the certain desired temperature, then never that chapati will be bubbled. So these are our day-to-day life in the kitchen. Besides that, we use the electric heaters in our bathroom, geysers. So all these are nothing but the supply for your energy sources. You want a higher temperature water. You put the solar heaters, rooftop solar heaters, water heaters. That is by the process of radiation. The sun heat that is stored or absorbed by the glass tubes or the copper tubes. As a result, the fluid which is inside these glass tubes get heated, and the water that will be becomes hot. This process happens whole day, and next day you get a higher temperature. Similarly is the case for your solar panels, the generation of electricity, the heat energy that is converted into the electrical energy. In case of solar water heaters, heat energy that is converted into heating the water, the solar energy that is converted into the heating the water. So all these are our different purposes that we come across in our day-to-day life. Now what happens in the industries? Industries we call the heat exchangers, evaporators, boilers, reboilers, condensers. All these are the different terminologies that is coming across. However, the purpose is the same, that is to exchange the heat. That is, the heat is getting exchanged. So when you talk related to the heat exchanger, one fluid which is at a higher temperature and the another fluid which is at a lower temperature, they exchange the heat and the desired temperature that is obtained. Accordingly, we keep the flow rates, we keep the temperatures so that we get the desired temperature for the process fluid. One is the utility fluid and the another is the process fluid. We are concerned about the process fluid, the fluid which is getting heated or which is getting cooled. जो मेरा concerned fluid रहेगा वो fluid मेरा process fluid रहेगा. The other is the supporting which is getting exchanging the heat. A cooler, in case of a cooler, if say a kerosene that is to be heated from say 70 degrees Celsius to the 50 degrees Celsius in a heat exchanger. Now it is cooled with a cold water. So cold water that will become a process fluid in this case. However, cold water, that will become the utilities in this case, and the kerosene, that will be the process fluid, because my process fluid is the kerosene which is of a concern. I want a kerosene temperature from 70 degrees Celsius to the 50 degrees Celsius. So this is my objective. Depending on my objective, I am reducing the temperature of a kerosene from 70 degrees Celsius to 50 degrees Celsius. I call it as a cooler. I call it as a cooler. However, for the utility fluid which is water, its temperature increases from say 25 degrees Celsius to 33 degrees Celsius. The outlet temperature of this cold water is not that much concern for me. I am concerned with the process fluid temperature and the process fluid flow rate. So depending on the process fluid temperature and process fluid flow rates, I have to manipulate the flow rate and the temperatures of the utility. Similarly, a heat exchanger that is there. A crude oil, you are heating it from say 50 degrees Celsius to 90 degrees Celsius in a heat exchanger. For that purpose, you are using the Dowtherm. There, the heat that is getting exchanged between the heating fluid Dowtherm, that becomes your utility, and the crude, that becomes your process fluid. Because our concern, it is called a heater, where the process fluid temperature is getting heated. It is called a heater. Where the process fluid temperature is getting cooled, it is called a cooler. Then what is a evaporator or what is a boiler? In both the evaporator and boiler, the same, you are boiling. You are separating the vapors, but the evaporator, your concentrated liquid that is of a concern, concentration of a fruit juices, that is carried out in a evaporator. Concentration of a fruit juices, a concentration of a milk, that is of, I want a concentrated product. So whatever the amount of the vapors that is going out, that is, I'm not bothered about that. Whatever the concentrated fluid, whatever the concentrated juice I will be getting, that is of my concern. So it is called a evaporator. In case of a boiler, the vapors that is of concern. The vapors that is of concern. In case of a reboiler, the vapors that is concerned. However, I am going to again and again boil the same fluid. That is why it is called a reboiler. These reboilers are associated with your distillation columns. Bottom of a distillation column, you are going to put a reboiler. So these reboilers, that is of concern. Then a condenser, a phase change that is observed. But what is concerned? From vapors to liquid, that is of concern. Vapors to liquid, that is of a concern. That is called a reboiler. That is called a condenser. That means I am going to condense the vapors and I will get a condensed product. How much amount of the vapors that will be getting condensed, this is of my concern. That is why it is called a condenser. So depending on the function, depending on the end product of the process fluid, I call the same heat exchanger as a heater, as a cooler, as a condenser, as a evaporator or boiler or a reboiler. They are nothing but your heat exchangers with slight modifications depending on the requirement. So this is what is happening in case of our industries. Now the next point that is related to the concern of this subject related to the campus interviews. This is most important concern for this subject. Now in final year you should be ready with one or the other subjects. There are heat transfer, mass transfer, fluid mechanics. These are the common three subjects on which you can be questioned in your interviews. So, preparing this subject of heat transfer will give you the confidence and the surety for getting selected in your campus interview. Not only that, in GATE also, this subject is having its own weightage. So what is the question that is being asked in case of this heat transfer? That is, the most common question is how will you design a heat exchanger? This is the most common question which is being asked in maximum number of the interviews when you convey them that yes, I like the heat transfer subject. Then your question will be how will you design a heat exchanger? So you should be thorough with the designing process and the basic fundamentals of the heat transfer, that is your conduction, convection, radiation, then insulation, then different resistances, all different numbers, different equations which will be used for calculation of the heat transfer coefficients. So all these basic things that is asked according to this question of how will you design a heat exchanger. For that, we should be able to answer this question in detail. For that, you have to prepare the detailed study, detailed designing procedure that is to be studied, understood, mugged up. Then and only then your confidence level that will be observed and noted by the interviewer. So, when you say, I like a heat transfer, your question is, how will you design a heat exchanger? So, for that purpose, we will today talk how to design a heat exchanger globally in general case. So, first I have to collect the different properties. Which properties I will require? I will require the thermal conductivity. I will require the thermal diffusivity, CP heat capacities, densities I will require. Then what are their concerned units that I should know. Then next is the selection of the type of a heat exchanger. How I am going to select a different type of a heat exchanger, whether I am going to select a shell and tube heat exchanger or a plate type of heat exchanger or a spiral tube heat exchanger or a double pipe heat exchanger. There are different types of heat exchangers. So out from the different types, which type of the heat exchanger I am going to select, and accordingly a slight modification in the design can be there, but it's a generally that is talked related to the designing of a shell and tube heat exchanger. Then what are the different heat duties that is associated with the process fluid? That means we have talked that is the kerosene that is to be heated from is to be cooled from 70 degrees Celsius to the 50 degrees Celsius. This is of my concern. Now what will be its flow rate? Say 10,000 kgs per hour, that is my flow rate. to cool this kerosene from 70 degrees Celsius to 50 degrees Celsius with the flow rate of 10,000 kgs per hour. How much amount of the cooling water that will be required? How much, what will be the temperature, inlet temperature, what will be the outlet temperature? I have to all decide these things. So I have to simply use the formula Q, which is equal to mCp delta T. This is all what we have studied in case of our previous classes also. That is the designing part. So heat duties that will be calculated. Then the area calculations. What should be the area of heat exchange between the cold water and the kerosene? So this area calculation that is of a concern after the calculation of Q, which is equal to mCp delta T. Now delta T is nothing but your log mean temperature difference, LMTD. So how to calculate the LMTD? That is for the higher temperature, the parallel flow, cross flow, counter current flow. These are the different flow arrangements. Depending on that, the LMTD that is to be calculated. Then we are concerned about the exchanger layout. Here the details related to the exchanger layout that will be focused. So what will be the exchanger layout? That means once I have calculated the area of a shell and tube heat exchanger, this much amount of the area that is required to exchange the heat, area of a metal, because the two fluids they are to be kept separated. So a metal pipe which is going to separate the two fluids, the hot fluid and the cold fluid. So I am going to have the first calculated the area. Then what will be the diameter of that pipe? What will be the length of that pipe? Then how I am going to arrange these pipes in the compact or minimum volume so that my costing or cost of fabrication of heat exchanger that will be minimum. So all these heat transfer equipments, their exchanger layout or how this designing that will be of a concern that is to be kept in the mind. Then after the calculation or after deciding the dimensions of a tube, that is the length, the diameter of the tube, then how they are to be arranged, then how many number of passes, that is whether it's a single pass or double pass, that will be there. So this number of passes that will be of concern. Then the calculation of a velocity, what will be the velocity for that? Then what will be the dimensions of the complete shell and tube heat exchanger? How many number of tubes that will be required? How many number of passes that will be required? What will be the bundle diameter? To increase the turbulence, how many number of baffles that will be required? What will be the spacing between the two baffles so that I am going to increase the turbulence? Turbulence increases the heat transfer. So minimum area that will be reduced. More the heat transfer, lesser will be the area. So that is all depending part. Then the calculation of the heat transfer coefficients. Heat transfer coefficients on the tube side and heat transfer coefficients on the shell side. So first, to calculate the velocities in the tube, velocity of a fluid flowing through the tube. For that, you have already calculated the area of a shell and tube heat exchanger, then the number of tubes in the one pass that is to be calculated, then the velocity through each tube that will be calculated. After that, you have to manipulate with the different equations heat to calculate the heat transfer coefficients. Generally, it's a Nusselt's number, that is Hd upon K, then your Prandtl number, Cp mu upon K, and the Reynolds number, that is du rho upon mu. So all these different numbers, Nusselt's number, Prandtl number, Reynolds number, that will be required, and a certain relationship between these numbers that is also is of a concern. So this related to the calculation of a velocity, then the calculation of a heat transfer coefficient on a shell side, on a tube side. Then similarly, I have to calculate the heat transfer coefficients on a tube side or shell side also. So I have to calculate the shell side fluid velocity. Then the shell side fluid velocity, what will be the area for fluid to flow, that is to be calculated by using the different formulas. How the pitch arrangement that is there, how the tubes that is arranged in triangular pitch or square pitch or rotated square pitch arrangement. Depending on that, I have to calculate the velocity on the shell side. Then what will be the heat transfer coefficients on the shell side. Once the different heat transfer coefficient that is calculated, then I have to calculate the overall heat transfer coefficient. Overall heat transfer coefficient that incorporates the different resistances, which is going to reduce the heat exchange process. That means a metal wall that is there, a certain fouling or certain deposits which is available on both the sides of the tube, that is metal wall. So then the liquid film resistance that will be there. So in all general, there are 5 resistances that is to be considered: the liquid film, the fouling resistance, the metal wall resistance on both the sides. So it becomes your 5 resistances. So you have calculated the overall resistance, overall heat transfer coefficient. From there you are going to calculate and compare this overall heat transfer coefficient with the assumed one, so that if they matches, then it is well and good. Then again, if it doesn't match, then you have to recalculate it, again define the exchanger layout, again calculate the heat transfer coefficient, and you get an optimized design for the heat exchanger, which will be fabricated at a lower cost and which will give you the higher heat transfer coefficients with the minimum cost. That is what is my ultimate aim, to reduce the cost of equipment and get the most efficient energy exchange. And to design this, I require the basic understanding of the heat transfer, that is your conduction, convection and radiation. Now, while answering all these questions related to the designing of the heat exchanger, in addition to that, can be asked the other associated questions. Say how the heat that is going to exchange, whether it is by a conduction or whether it is by a convection or whether it is by radiation. Then what do you mean by conduction? What do you mean by convection? Then similarly, you can be asked with the different types of resistances. What are the different types of resistances there are? Then what are the different types of the foulings that is going to take place? Now this is what we have talked about the exchanger that is to be fabricated. If you are already having an exchanger, then how you are going to use that available exchanger for a specific purpose? That is, you are going to calculate its effectiveness. That is the second method, to calculate the effectiveness, to calculate the number of transfer units, and manipulate with all these things. So one has to understand, apply the different concepts of heat transfer, basic concepts of heat transfer, and should be able to give you the details of the answers, then with all your cleared fundamentals, and that should be with your confidence level. So you require the understanding of the designing of shell and tube heat exchanger. This is the most common question that is being asked in your campus interviews, and you should be able to answer it. That is of concern, that is of the outcome of this subject. You should be thorough with the designing procedure for any of the heat exchanger. Most of the heat exchanger designing, that is more or less similar. However, the different exchanger layout configurations, it can vary, or different some manipulations in the different formulas for calculation of the overall heat transfer coefficients, calculation of the Reynolds number. The slight changes and modifications depending on the type of a exchanger which you are going to select. So all these are the different heat transfer or the heat exchange equipments and the designing purpose of